Ever pondered the probability of other universes existing concurrently with ours? Welcome to the mind-bending conundrum of the multiverse. The multiverse, as it's typically understood, is a hypothetical collection of multiple universes, our own included. It's a concept that stretches our understanding of reality and forces us to contemplate the unimaginable vastness of existence. Now, what exactly do we mean by universe? It's everything that you, I, and every creature that ever lived have ever known. It's the entirety of space and time, every atom and particle of matter, every joule of energy, every law of physics and every constant that governs them. It's an all-encompassing term for all that is, was, or ever will be. But the multiverse theory dares to suggest that our universe, with its billions of galaxies and untold trillions of stars, is not all there is. It proposes that there could be other universes, perhaps an infinite number of them, existing in parallel to ours. These universes could be similar to ours, obeying the same laws of physics and housing similar galaxies, stars, and planets. Or they could be radically different, with entirely unique laws of physics, matter, and energy. To truly understand the concept of the multiverse, we have to let go of our preconceived notions about reality. We must abandon the idea that our universe is the only stage upon which the drama of existence unfolds. We must entertain the possibility that there are countless stages, with countless stories playing out across a cosmic theater of unimaginable scale. It's a tantalizing thought, isn't it? A cosmos, teeming with an infinite array of universes, each one a unique realm of possibility. But it's important to remember that the multiverse is still a hypothesis. It's a concept that scientists are exploring and debating, but one that remains unproven. Imagine the implications if we were to affirm the existence of these multiverses. For now, though, we can only speculate and marvel at the grandeur of the universe we know, and the potential infinity of those we have yet to discover. One of the most popular interpretations of the multiverse is the many worlds theory. Let's sink our teeth into this concept. Imagine you're at a crossroads and you can either turn left or right. According to the many worlds interpretation, in one universe, you turn left, and in another, you turn right. Essentially, every decision you make, every chance event creates a fork in the road, and an alternate universe is born for each possible outcome. Now, this might seem like pure science fiction, but it's actually a serious interpretation of quantum mechanics, the theory that describes the behavior of particles on the tiniest scales. The many worlds theory is a brainchild of the strange world of quantum mechanics. In this world, particles can exist in multiple states at once, a phenomenon known as superposition. However, once we observe these particles, they seem to choose one state. This is where the many worlds theory steps in. It suggests that all possible states that these particles can be in do exist, just in different universes. So when we observe a particle in one state, there's another universe where the particle is in a different state. It's like having your cake and eating it too, but in different universes. This theory can be a bit mind-bending, but it's a real attempt to explain the weirdness that is quantum mechanics. It's an interpretation that takes the mathematics of quantum mechanics seriously and paints a picture of a truly fantastical multiverse where every possibility is played out. But it's important to note that these aren't parallel universes in the sense of being next door to our universe. They're not places we can visit or communicate with. They're alternate histories, different versions of reality that exist independently of each other. In essence, every decision you make could potentially spawn an infinite number of universes. So next time you're deciding whether to have tea or coffee, remember that in some universe, you're having both. Another intriguing proposition is the theory of cosmic inflation and bubble universes. This theory originates from the concept of cosmic inflation, a rapid expansion of the universe that occurred a mere fraction of a second after the Big Bang. This idea, first proposed by physicist Alan Guth in the late 20th century, suggests that the universe expanded at an exponential rate, going from subatomic size to cosmological size almost instantaneously. Now, if we apply this theory on an even grander scale, it leads us to the concept of bubble universes. Picture a cosmic soup, a vast, superdense field of energy. Within this soup, certain regions undergo inflation, ballooning out at an incredible speed. These ballooning regions are what we call bubble universes. Each of these bubbles is a universe in its own right, with its own laws of physics, its own galaxies, stars, and maybe even life. Our universe, in this context, is just one of these bubbles. It's like we're living inside a bubble floating in a cosmic ocean of other bubbles. But here's the kicker. Each of these bubbles could have different physical laws. Imagine a universe where gravity is 10 times stronger, or where time flows backwards. These aren't just fantasies, they're possibilities in the framework of bubble universes. This theory gives an entirely new perspective to the concept of the multiverse. It's not just about parallel worlds or alternate timelines. It's about a vast cosmic landscape filled with an infinite number of universes, each unique and distinct. But as mind-bending as this concept is, it's also deeply humbling. If our universe is just one bubble among countless others, what does that say about our place in the cosmos? It's a question that challenges our understanding of reality and our place within it. Imagine a cosmic bubble bath with each bubble representing a different universe. What evidence do we have to support these theories, and why are some scientists skeptical? Let's dive into this. To begin with, much of the evidence supporting the multiverse theory comes from the field of quantum physics. The concept of quantum superposition, for instance, suggests that all possible states of a particle exist simultaneously until observed. This idea lends credence to the many worlds interpretation, proposing the existence of parallel universes. Moreover, patterns observed in cosmic radiation have also been interpreted as potential clues. Some cosmologists suggest that these patterns could be the result of collisions between our universe and others. However, this evidence is circumstantial at best, as these patterns could also be explained by other phenomena within our own universe. Now let's flip the coin and examine the skepticism surrounding the multiverse theory. The main criticism lies in the lack of empirical evidence and testability. Unlike most scientific theories, the multiverse concept doesn't make predictions that can be tested. It's challenging, if not impossible, to gather physical evidence of other universes. Critics argue that the multiverse theory, while mathematically elegant and philosophically appealing, strays into the realm of metaphysics, rather than remaining strictly within the bounds of empirical science. They maintain that without direct observational evidence, the multiverse theory remains a speculative idea. Additionally, the multiverse theory is often accused of being a theory of anything. If an infinite number of universes exist with all possible physical laws, then anything and everything is not only possible, but inevitable. This idea, critics argue, makes the theory unscientific since it can be used to explain any observation, rendering it unfalsifiable. Ultimately, the multiverse theory, despite its captivating allure, is a subject of intense debate among scientists. The quest for understanding our universe, and potentially others, continues, with each discovery and theory adding another piece to the cosmic jigsaw puzzle. The multiverse theory, while fascinating, remains a topic of intense debate among scientists. What would it mean for us if the multiverse were indeed real? This question has been the subject of much debate, and the implications are enormous, both philosophically and scientifically. From a philosophical perspective, the existence of a multiverse could lead us to question our significance in the grand scheme of things. If there are countless other universes with countless versions of ourselves, what makes our existence in this universe special? It could redefine our understanding of selfhood and uniqueness. It could also pose new questions about fate, free will, and the nature of reality itself. Are we just one of many possible versions of ourselves, living out one of many possible realities? Scientifically, a multiverse could shake the very foundations of our understanding of the laws of physics. If there are universes where the laws of physics are significantly different from ours, it could mean that our laws are not universal, but local. It could mean that what we consider to be fundamental principles are merely the product of our specific universe's conditions. This could lead to a revolution in how we understand and study the physical world. The existence of a multiverse could also have implications for our understanding of the cosmos. It could change how we view our place in the universe, making us realize that we are just a small part of a much larger, more complex cosmic landscape. It could inspire us to explore and understand the cosmos on a much deeper level. It is important to remember, however, that these are all speculative implications. The multiverse is still a theoretical concept, and we are far from having concrete evidence to support its existence. Nevertheless, It is a fascinating idea that continues to captivate scientists and philosophers alike, pushing the boundaries of our knowledge and understanding. The multiverse, if real, could redefine our understanding of existence itself.